Hi everyone, I'm Wei-Ju. I'm going to present new series 3D shapeforming with modularized serial connected inflatable. Author including me, Yu-Wen, Chen, and Professor Longpan. Let's start with the video. So new series is a series of modularized inflatables, where the inflation and deflations are propagated in between stage by stage to form various shapes. That is, our modularized inflatables can be inflated, deflated by just using one pump. And as you can see, we only use one tube to form various shapes. Alright, it all begins with shape-changing interface. Shape-changing interface enable computers to physically interact with users. They achieve it by dynamically transform its shape. There are many approaches to reach different functionality and use in different application scenarios. For example, inform and shape bots control the extrusion of linear actuators on a table, while transform transform between a straight line and a curved shape. Recently, researchers also have tried to use soft materials such as fabrics, inflatables, papers, and tapes to implement shape-changing interface. Among all these approaches, pneumatic shape-changing interface have a great potential for minimizing device form factors because they are lightweight and able to change the volume freely to form various shapes. Here shows some examples of using one inflatable to implement shape-changing interface. New fabricates a preconfigured inflatable to be changed its shape progressively. Inflatable mouse also use one inflatable to change the shape of the mouse to indicate different contexts. If we use more inflatables, the shape forming will be more flexible. Here are the examples of multi-inflatable systems. Tile pop and lift tile both use inflatables array to dynamically transform its shapes. Pew pop tie all folded inflatables together and inflate the right one to present the right shape at the right moment. However, each inflatable requires a tube and one active valve to control, limiting its freedom to be laid out freely. Since more actuators would limit the layout, the main challenge in current multi-inflatable system is that more actuators, less freedom, because of the layout constraint, which contradict what we have known in the engineering that more actuators equals more freedom. Recently, we found a work that used a serial control system to control the inflatables in a soft robot, which brings us a silver lining to control the inflatable system process in time domain rather than in space. Therefore, we propose new series which integrate the serial control system into multi-inflatable system for shape-changing interface. Unlike traditional multi-inflatable systems that duplicate a single inflatable system and have proportional number of actuators, new series use only one actuators to control all inflatables. This eliminates the layout constraint from external tubes, which largely reduce the complexity of the system. Alright, so that's new series. Next, I'll elaborate more how new series works, including its inflatables, its serial connection, and how to program new series. Let's see the first part. We make four kinds of polyhedral inflatables, such as cubic, cuboidal, tetrahedral, and prisms, as basic units of new series. These inflatables can be folded properly when deflated, as we attach the cardboards on the surface to maintain the surface tension. Secondly, we need to connect these inflatables to enable serial control. We use check valve to connect inflatables. The check valve is composed of a tube, a steel ball, and a spring. We combine two valves in opposite directions and install them between the inflatables. The working principle of the valve is, if the pressure difference is large enough, the airflow can pass through the valve from the high pressure side to the low pressure side. To make it easier for assembling, we make fast connectors with the valve embedded inside. We have seen this in the video at the beginning. We can easily connect or disconnect the inflatables by just screw them together. The last part, serial programming. To make the multi-inflatable system to reach the target shape, the system has to figure out a sequence of inflating and deflating operations. Here is an example. Consider the inflatables are connected in series, with one end connected to the pressure source. Here are the original shape and the target shape. To reach the target shape, we divide and conquer to make the rightmost inflatables to match the target shape. That is, here the system keeps pumping in until the rightmost is inflated. As the rightmost is inflated, the system then considers the second rightmost and so on. So we inflated the inflatables one by one until all inflatables reach the target state. Finally, that's what we see in the video from the beginning. Now we know how NeuSeries works. We move on to more technical detail. We particularly were interested in the flow rate of the system. So we formulate a flow model regarding the ith inflatables. That is, the net flow dni dt equals inlet flow plus outlet flow. We conduct an experiment to measure the flow rate under different pressure. As you can see, the cracking pressure of the valve, the flow rate increased significantly as the valve now is pushed to open. That is, by changing the cracking pressure, we can change the flow rate response of the system. With this experiment result, we used the above equation to simulate the inflating process. We found that the last half need more time to be inflated. So we changed the last half valve to the smaller cracking pressure one. To accelerate the inflation. Finally, we conduct an experiment to verify the simulation result, which matches our expectation. Next, we develop applications for NeuSeries. We develop a software to explore the shapeforming of NeuSeries. In this example, we made a 3D array of cubic inflatables, which can form not only 2.5D but also overhanging structure. Second, here shows three examples. The first one is a smart holder. Its tilt angle can be programmed by changing the number of inflated inflatables. Second one is a shelf that can inflate it for users or deflate it for storage. The last one is using customized inflatables to transform between a sword and a ball. Note that the ball actually grows out from the sword. To conclude, we have presented NeuSeries, the serial control multi-inflatable system that eliminates the layout constraint and increase the system's scalability. Second, we conduct experiment and simulation to get deeper understanding of the system behavior. Third, we made several working prototypes to demonstrate the potential applications of NeuSeries. Thank you for listening. If you want to know more details, please refer to our paper and contact me. Thank you.